Git, but it has a fancy name so that people would maybe be interested. So what I want to talk about is a bit of background first about the version control we have in Pharo, what it looks like now, and what it could look like in the future, and along the way there will be some Git. So this is Konrad Zuse with his first cool computer. Sorry?
That was not his first.
No, not his first, but it was an old computer. Sorry, yeah, I'm Max. Leske, by the way. So a lot of this information on this slide comes from Dale, so he is my personal historian in this case. So things seem to start with SCCS as one of the first version control systems. Then there was sort of RCS. If I get it wrong, please don't hate me. Then there was CBS, and so these are sort of the centralized systems, and then there also is a BitKeeper for the Linux kernel, and I just use random selection, right, monotone, and now the newest ones, sort of Mercurial and Git. There are a lot more, but just to show you sort of the cornerstones. And the way it was in Squeak and Pharo was that there was RCS and basically one file, and then CBS with more than one file, and then apparently Avi Bryant wrote DBS to have some sort of source control inside the image. Then came Monticello, which, well, basically DBS was expanded and then renamed. And then there should have been Monticello 2. According to Dale, there was a problem with ordered sets. Sounds funny, but because sets have different orderings in different platforms, you could not create a hash that was stable across platforms. So that was the bug that essentially killed Monticello 2. Which was unfortunate because there were some very interesting ideas in there. So yeah, about Git. This is actually, so when you read the C files in Git, you have the stupid content tracker from HAL all over the place, so they're quite funny. Just for those who don't know Git, you have references which are basically pointers to some, let's say, no, not lots. Let's say like package versions, right? The package versions in case of Git are commits. A single commit denotes a single version, and a commit has a single tree. This tree can have trees or blobs as children, and leaf nodes are always blobs or trees. So very simple. Then there are Git repositories, which are the thing that holds all those objects. And the sort of the accepted workflow mostly is that you have some local repository on your machine, and then there are other people who also have local repositories on their machines. And then there's like GitHub, right? There's a remote repository which synchronizes across these repositories, and usually there's a few people who control the remote repository and sort of say what is a good change and whatnot. Git has a few protocols which are quite nice to do the networking stuff. There's the normal file protocol, so you can just talk to local repositories. There's the done protocol, as they call it, which is very fast but inconvenient because it doesn't have any authentication. Then there's SSH, which is the one that most people use, and of course HTTPS and HTTP, which mainly is used for pulling stuff, so getting stuff from a remote repository to your local copy. But with HTTPS you also have authentication, which means that you can also push. Why I'm talking about this still today. Alright, so what is the current state? So this is probably not how Monticello really works, but I feel like it does. So you have some code piece, some artifact, which goes into Monticello, then it goes into a black hole, and out comes an MCZ file. So recent developments came up with this thing here. So recent, I don't know when that STIC conference was, like 3 or 4 years ago, I think, where Dale and a few other people gave Cypress life. And at the moment, Cypress, most people know it as file tree probably, is this, basically it's just an abstraction of the Smalltalk hierarchy with metadata, and then you get directories and files, which you can put in under any version of control or do whatever you like with it. So I've tried to find a few problems. This is not, don't think of this as a critique. This is just stuff that I personally experienced or personally think that is a problem. So you have a single file essentially instead of objects. So you have to, I mean, I don't know what the alternative is, but you have to deal with bits and bytes. And then it uses this awful chunk file format, which I don't like at all. One of the worst things in my mind about Monticello is that it tracks versions by file name. Although there is a UID hash for every version, which lets you construct the ancestry, but it just doesn't get used. And it's very hard to understand. So Cypress is a cool idea to sort of get away from that and go some other direction. But it also has a few problems. First I want to tell you, of course, about how it works. So with Git, you have a package version which corresponds to a commit. Then you have the categories like category and protocol, which correspond to directories, and metadata and source code, which are blobs. So blobs are always just any data. So the problems in Cypress, which are not inherently a problem of Cypress, are moves and renames. Monticello can't do that. Then you get very, very deep directory structures in certain cases, and which is a pain to look at. Again, files instead of objects, and this is a bummer at the moment. When you get a file tree repository, you open it up, you always see only one version. The only way to have multiple versions is to basically cheat and load the version into Monticello, then go to the file system, check out a different version, go back into your image, and do the same thing again, and then you can see them side by side, but you can still not do diff or whatever. Unless you have the merge driver by here. Hard to merge. So, and then there's Metamodel, which I think we can all agree is a great addition with a few quirks. So basically there's a specification that says, okay, there's a platform, and if that platform is there, then take some packages that correspond to that platform, and then you get a fixed loadable unit, and this loadable unit is defined forever, and you can always load it again with the same configuration. So that's cool, so you don't have to keep in mind, oh wait, when I'm on suite 3.6 I have to load version 1.3.5, but that doesn't work on Pharo because they changed the compilers. Yeah, so I've had the joy to jump into the Metamodel code a few times, and it sort of reflects how Monticello works. And yeah, it's hard to maintain the configuration files when your project grows, and also the learning curve for scripting is very steep, although Dale has developed some scripting mechanisms that make it easy. So yeah, how could the future look? I'm not going to tell you this is how it's going to be. I just want to sort of give you an idea of what we are working on. So, first thing I want to stress is I'm not advocating that we get rid of Monticello tomorrow, because I have not seen a replacement yet. But maybe we could take steps to sort of, I don't know, make leaner and then have an option to chuck it out and put something else in. I don't know. So can code, then Monticello, then the black hole. And now, what about if we instead have MCZ files which just say, okay, let's type in arbitrary backend, like for instance, Cypress and this. Or I don't know, there could be any number of things, right? So there's this interesting master's thesis by Matthias Kleiner, an abstraction for version control systems. And what he basically tried is, like he took Mercurial and Git and SVN, and then he tried to write, for Newspeak, an abstraction layer which exposed an API to the version control system, so the version control system could ask for versions, and then there was some magic that would sort of generate objects, right? Which I think is a good idea. I think that the thing that didn't work, from my perspective in the master's thesis, was that I think you have to look at the model first and decide what model you want for version control, and then just plug in the backend, right, the storage. And the model should not be dependent on the storage, so you don't want to restrict the API too much. So basically it would flip the thing that he said around. So in Pharo 2 we had something like this. We had Monticello, and then Monticello has this Metamodel for building versions that it needs, because, well, you have to do this atomic loads thing and stuff. And then we have Monticello. And currently we have also Monticello and Monticello, but instead of the Monticello Metamodel, we have Ring. So Ring is basically does the Metamodel thing, and so it takes away responsibility from Monticello and already makes it more easy to swap out if you want to. But still, Monticello will decide what does the version look like. So since I've been developing Git for quite a while, I sort of always try to go in this direction. I think it's not bad. So you'll have Monticello, Ring, at least for the near future. And then, so somewhere will be Git, right? And then right now developing Git bindings through native boost. And then there will be a Git adapter that somehow takes the Metamodel and builds a representation of the file system. So now, what I said before was that we want to arbitrary backend, right? So maybe we could have Mercurial or anything there, and we would have this modularity and the possibility to react to the future. Like, I don't know, maybe like someday there will be something better than Git, and then we can use something else. Or, I don't know, someone will develop bindings for Mercurial, and then we can use that. So this is what I said before. You want to have a versioning model, and then in case of Git, you will map to commit, tree, log references. In case of Mercurial or some other thing, you will just do what you have to, but the model should not have to care about that. So as some of you might know, I'm developing the Git bindings with Liveget 2, which is a library which is still under development, but they are making fast progress. So why am I using it? Because it's well documented, it's easy to understand, there's fast response from the community, and one of the coolest things is if you use such a library, you're not required to have Git on your host. Right? I mean, if you use FileTree today, you're still pretty much required to have Git installed, use the command line for some stuff. You don't want that. You want it to, for new users especially, you want to that it works out of the box. And one very important thing is it's not maintained by us, so we can take the load off the community. and obviously you can compile it to whatever platform you like. So, I'm going to show you a few things that I've been working on. Is that too small? Can you read it? So, this is GT Inspector and Moose, and so this is one of my Git repositories. If I inspect this, I get, for instance, a branches tag on which I can see, oh, I have a master branch, right? Okay. So let's go to my other image. Just let me show you. So this is my stuff repository. If I do git, can you read that? Probably not. If I do git branch -a, you can see I have branches master and 2 remotes, but there's basically only one branch. Okay. So what I'm going to do now is I'm going to run a test which creates a new commit in a new branch and then pushes that to my GitHub repository, which I will show you so that you know that there's no magic happening. So you can see here there's only one branch there. So if I run this test, and I hope it works, and refresh this page, you will see that I now have a new branch here called Liveget with a folder inside and a file. Right? So, okay, that seems to work. Remember, this is all through the Liveget 2 library. So, okay. So what I'm going to do now is I'm going to pull that branch that I just pushed. Oh, look here, I have a new branch, right, which is called Liveget. And, yeah, just to show you that this is not actually all fake, if I refresh this, it doesn't work for some reason. Yeah, okay, so this was supposed to work. Anyway, what we would see is that you get 2 branches here.
Can you list the remotes in the command line?
Oh, okay. Let me quickly. Okay, there we go. So now we have both branches listed here. And what I can do now, as you saw on the command line, I checked out master. And I'm going to check out Liveget, the Liveget branch through the library. I'll do this. If I do something here, you will see that my branch tag here is switched to Liveget. So I can actually already check out push, pull, fetch, commits, do that sort of things all through from the image.
And what is missing?
Everything else.
So for instance, so like merging is obviously a thing, right?
Yeah, you can, I think it's all about
Version
Yeah. There's not. I'm not saying there's much missing. I'm just saying it's not quite there yet. So there's bits and pieces that are.
Because how you could merge the metadata.
Yeah.
You probably do that with one.
Yeah. No, but for instance, like if I run status, I still have to check that there are no untracked files because otherwise the VM will crash. And so.
Why was last year when you were using the debug VM?
Because the VM crashes a lot. And I have to go there and look at the invocations. Okay. Oh yeah, there was one other thing I wanted to show. In this playground here. In this playground here. So this is also pretty cool. This is something sort of unrelated, but so for those of you who know file tree, basically you just dump representation of files to the disk, right? And currently this is implemented in the file tree package. Now Camillo Bruni developed this little thingy, which is called Filesystem ST, which is basically an extension of file system. And what it does is it pretends that files and classes and methods are files. And what you can do now is you can browse the Smalltalk code as files, right? And so if I click this package, for instance, and say export, I will so you see I get a dump of the stuff here that I just saw. And it's a lot easier than having to code for file tree explicitly. So that was one thing. And the other one was not that. Okay. Yeah, I think I'm going to finish the presentation. I have a little bit more to show if you want to see it, but it's not that cool. All right. Just a couple of random thoughts. I've talked to a lot of people this week, and yeah, just want to share what we talked about. So Stefan Eckermont came to me and said, well, if you say arbitrary backends, why don't we just put a P2P backend in? Which I